two interesting developments this month from the Wikipedia world. One is that there's been an article published about groove shadows. This is a concept that I was involved in the creation of in the early 2000s, late 1999. And it's basically the ability to combine sound effects, make them musical, and then create a bunch of stuff to support a existing composition or production. So that's number one, that article has been published recently. There's been a little bit of churning on stuff about groove shadows lately. So anyway, I'll include the article link in the description. Second thing is that I have been working on an article about audio source separation for Wikipedia, and I'll include that in the description as well. And this article is basically a way to have a centralized place to wrap one's head around some of the things that are going on in source audio separation or audio source separation or stem separation or stem splitting. It goes on and on and on with this stuff. And basically it's like a Cambrian explosion for remixing things and touching up things. And it's basically starting to really become more popular, especially in the last couple of years, only because the quality of the algorithms has substantially improved. So we couldn't even basically separate a vocal from an instrumental, like in the 2010s with really good results. But here in the 2020s, we can now split things into 4 groups of instruments from one file. So the real quick thing about source separation, audio source separation, which is also called music source separation. Probably the best term in the context of music is to use the word or the, saying music source separation. But if you're going to use it, because this is the thing with source separation, is it starts with something called signal separation. And it has all these different things that are applicable to what you can do when you're messing with signals. So I'll give a real brief on that since I've started a video here. With signal separation, the whole point of it is basically you would take what's called a mixture and you're breaking it apart using targets. And targets, that's where things get tricky, because the way you go about establishing what you're trying to sort of extract, and they call it separate, but what you're trying to extract from this is some kind of specified model of something, and you're using many different approaches to do this, and using deep learning, all that deep learning stuff, for the most part, you combine it with math, which looks at parameters of spectral stuff that involve time and frequency, and you combine that along with what's called these data sets, and the data sets are just basically recordings. But the tricky part about all this is that at first glance, people just assume you could just dump a bunch of recordings into these learning systems to train the data and train the model. And so, but really what they were doing was they were using a finished piece, and then they were getting actual real stems. And from those, they were creating the way to fingerprint what is actually going on with individual sounds. And so for whatever reason, they chose the basic 4 target group of a vocal, a bass, the drums, and then this other category. And in the last few, maybe months even, they're coming up with more capability to fine-tune what they search for in these mixtures. So that's kind of, in a nutshell, what's been happening with all this stuff. It's really a crazy explosion with stem separation happening. Now, the caveat is, of course, you're not going to go with a stem separation tool and pull out an exact replica that you would find like in a real mix where they produced a real stem. Of course you're not going to do that. And I'll tell you one reason why that I just happened to think of recently. When you're hearing a composition, what you're actually hearing a lot of the times in the modern era is maybe 50 different tracks. And the reality of what you hear, it may sound like it's an ensemble of maybe 5 instruments, but it's actually 50 or more. And when I was younger and I had more energy to put into all this stuff, my compositions, and also I had to do a lot more bouncing, but my compositions would have like 100 tracks. And I would say, well, now I have to stop this because I'm out of resources, I'm out of power. And so the idea that you're going to pull something of, pristine fidelity from this mixture, it just, you obviously can't do it just based on that alone, because there's groove shadows and all this stuff as well, which means there's things that were made to accentuate the sound that go beyond digital signal processing and more into dub. And so all the while, what you thought, or everybody thought, was like a drum or just a basic sound, may have had underpinnings that were fortifying what was actually going on. That's why they all sound like slightly different. And so something else was going on there, the dub part. So another great example is, so you have a classical orchestra, and then you have what's called MIDI mock-up. And so the idea that you're going to pull orchestral sounds out is a conundrum, because which ones are you pulling? Are you pulling the MIDI mock-up, or are you pulling the actual real stuff of the orchestra live played? So obviously it's not going to be either one. It's going to be a mixture, to use their word, but it's going to be a composite of those things. And so that's one reason that it's super difficult to get like a truly accurate stem. In reality, what would really be wonderful with these source audio separation tools is that if it pulls stuff and misses stuff, you can sort of go line by line and say, in this part, the attack of the guitar is missing, and perhaps the system could go and search that portion out. Because all that happens is, if there's something missing or there's something added, it's just in the wrong track of the final separation. So it's there and it exists, but it just didn't recognize it and fingerprint it properly. So it's just a case at this point of the spectral side. And so that's where other tools, like you can add in the human approach now, so that you could use something like a spectral layers or Ripex DAW, and you can actually visibly see, these representations of audio, and then thereby edit them so that they will further comply with your aspirations that you're wanting to achieve. Now I'm starting to sound like the Wikipedia article I made, which actually, the second one that I'm mentioning here is not actually published, but I'm going to include the link to the draft, and perhaps some actual experts in this, of which I'm not remotely involved with. I'm like 1% at best in terms of wrapping my head around this myself, but I definitely wanted to get a bird's eye view for various reasons of what this is capable of here in 2025. And so they've already been using the most powerful computational systems, and then they've already now recently optimized code and optimized their ways of doing things so that you're using less CPU, so therefore you can do it locally, which is the big new trend. Is you have this suites of company that can do like multiple things. Maybe they even have an API, and then secondarily you have these plugins and applications that can do local-based processing, and some of them actually will include both cloud and local processing. And initially, you really needed cloud-based processing because of the intensive computational needs, and would just really bog down your system. So that's, in a nutshell, what's going on here with these two developments with Wikipedia. And so Groove Shadows is something that I started like 20 years ago, as I mentioned. So it's really awesome that it's actually lingered around the music industry for so long. And another thing I'll mention is that there's actually been a few tracks that were released by DJs that and I might include them in the description as well, that they used the original Groove Shadow demo song for part of their mix. So you can hear my voice in the tracks. And I'm not gloating about this. What I'm trying to do is continue this concept of Groove Shadows with the designation that this other form of music exists out there that's been kind of like overshadowed by AI, and it's wonderful things you can do with that, especially in terms of interactivity and creation to some degree. But there's also this other side that we were working on with sound development and sound design, which was things like Groove Shadow and maybe whatever else would go in other directions with sound development. Because that's the whole point. We got our piano and we got our drums and we got our basic essential stuff. Now, what else, is interesting? So there's a novelty, randomness that's built into this concept because for the most part, at least right now, it takes a human to sort of listen to this and to say, well, that part of that Groove Shadow would work really great with this type of drum or with this type of piano or whatever. And so you can hear it and you can make the choice if you wanted to use it or part of it, maybe even spectral edit it. There's so many ways that you can adjust these things now that from when I started, it's in such an incredibly more advanced place to be able to further, contour all this stuff for whatever your desired outcome is. All right, I'll leave it at that. Have a good day.